Yeah, I guess I'm live now. So today I'm running a late bit, 6 minutes late, that's fine. Let's start the contest. Problem. Audible, right? I guess I'm live now. So today I'm running a late bit, that's 6 minutes audible. Please don't say today we have a maths problem. Takashi is developing a tax calculator system for a certain country. In this country, the tax amount on income is calculated according to the following rule. A tax rate of P% is applied for the first L, then a tax rate of Q is applied for the excluding. Okay, that's fine. Okay. Specifically, the tax amount T for a person with income SIN is calculated as this. Oh, they simply have given a formula. Okay, so we just need to simulate this. That's all I know. That's all like I feel. Yeah. Let me implement. So first is NL, P and Q. And L, P and Q. S is the salary. I'm a public, right? Yeah, public. That's fine. Hi Sahil. Hi. Thanks for joining. Just keep it interactive. If you don't know anything, just keep it ask, so that won't make me feel sleepy. So that's fine. So yeah, we have to just code this formula. We take the input. Can I do that? Can I open live stream here? I can then see the chats live. Wait a minute. Let me open stream here also. Switch account. Where can I find the live streams? Yeah. Wait. Okay, got it. Cool. I is equal to 0, I is less than n, I plus plus. Let me take s as an input. If s is less than l, if s is less than l, then we simply output t. This is the text. See out s into p by 100, s into p by 100. Oh, it should, no, okay, it's fine, it's a floor only. Otherwise we have to output l into p l into p plus s minus l divided by multiply q then divide by 100. That's all. I think should work. Yeah, let's submit and move to the next question. I think today's thumbnail is not correct, I guess. Yeah, this is not correct. Change. Oh, I can't we remove this? Okay, after stream I will update that. Fine. Got AC. Let's move to the second question. Cell cultivation. Takahashi is conducting a cell cultivation experiment in a biology laboratory. At the start of the experiment, there are S cell in the culture dish. This cell has a special property. When Takahashi performs one, all cell divides, okay, and the number of cell become double. The only means Takahashi change the number of cell is this promotion, mitosis promotion, mitosis. I don't know how to pronounce mitosis operation, and due to the nutrient limitations of the culture dish, this operation can be performed only be performed between 0 and k time. Okay, Takashi's experiment goal is to make the number of cells exactly t. Okay, determine whether it is possible to change from s to t. If it's possible, the minimum number of operation required. Okay, so we have only k operation. We have to use minimum operation, and our first goal is, can we achieve t? If it is we can achieve t, then our second goal is to minimize the operation. Okay. What we can do then? Wait, let me formulate this in my mind, like what they are. See, question. This type of, I like the problem statement of crisp and small, but the effect of this problem statement is huge, because on the first glow I'm unable to understand what to do itself. Let's see. See, firstly we have to, so see, t should be power of, t should be 2 to the, something that is 2 to the power, because it's doubling every time, right? Number of cell is getting double. So what I am giving a jargon is, initially we have one cell, right? Oh, we have S cell. No, we have S cell. Let's say we have this many cell. Become it double. If it is S, then it can become 2S, 4S, 8S, right? This way. This is what they are telling, right? Double. Oh, if it is S, then it is 4S, right? 4 and become 8S. Yeah, this is what, how they grow. We have 3. S is 3. Then it becomes 6. Then it becomes 12. Then it becomes 24. Yeah, that is the only choice we have. Why I'm getting confused? Yeah, this is the only choice we have, right? Either we can double or we can stop. That's all. S, see, we have S, T, and K, right? While S is smaller than T, we have to our answer plus plus, and S is into 2. So if S is equal to T, then we simply print our answer, else we print -1. Yeah, see, always try to simulate the problem into a visual form. See, let me submit and then give you the jargon if it is accepted. Yeah, it will accept. See what we saw, we have S source and we have to reach some target T. Only operation we have is you can multiply by 2 and you have to find the minimum. So only way you can is you can either multiply or you can either stop, but we are getting some wrong answer. That means we are missing something. We are missing something. What we are missing is it's 10 to the power 18, right? Oh, and here see, and also here we have to check that answer should less than equal to K, right? You can't perform more than K operation in. Yeah, this is what we are missing. That's all should work. It should work. It should work. Yeah, we got AC. Let's move to the third question. Before attempting the question, I have understood one pattern. They always include a difference array question in a weekday contest. So I'm hoping this is a difference array question. Takahashi has a sequence of n positive integers. The ith integer is ai. Okay. Takahashi is interested in the sum of continuous array this. He considers the sum of element is this. You are given integer k. Find the number of pair this such that the sum is at most k. They always bring interesting sub array question. See, we can do this question by prefix sum. I have an idea in my mind. Let me implement first and we'll explain later. N and K. Need to take input. Okay. N and K. I thought someone messaged on chat, but it's fine. There's no one. Okay. We have to find our answer. Let me declare answer is equal to 0. And also at most k. So we need we need actually is today we got one subscriber. Thanks for subscribing. New subscriber, I mean. We are growing, and at least one. That's not bad. So what I am thinking is I will maintain, let's say, map of int comma int mp, and the current sum is 0, sum plus is equal to a of I. So we need all the subarray whose sum is at most k, means k at most k or less than k or less than k. That means need is equal to k minus sum, right? We want a maximum sum should be k, and currently we have something that is in store in sum. Sorry. What we can do, we have to find all the see, if we iterate through map, then it give us a TLE. Oh, map is always sorted, right? But we can't. We want is number of pairs such that sum of that pair, see, I know, like, maximum is this, so we need to add all the such pairs. We'll do brute force first. We need to add all the such pair for now int current sum is equal to sum plus x dot first if less than equal to k, answer plus is equal to mp of x dot second, else break. This is what we want to do, but we have to somehow find optimal way. Oh, oops. Yeah, here we have to do mp of sum plus plus. Still something is missing then. You're getting 5. This is what, right? See, current sum is this. If I minus this and I have sums less than equal to k, then we have to add this much. What I'm doing is, see, I have a sum of this, right? Current sum, entire prefix. I have some prefixes like here, let's say this, let's say this, say this is 5, let's say this is 2, and this is also 2, and I left with 3, and let's say k is 7. K is 7. Then I have to, I have to do mp of 0 plus plus. Perfect. So see, I want this should be our answer. This array is also, like, for this array, this is our answer, right? See, our target k is 7, so sum of, like, any sub array whose sum is 5 is also our answer. Any sub array whose sum, say, currently we are iterating over a map. Let's say map, we are at a pair 2 comma 2, right? If we are, like, there is 2 pair whose prefix sum is 2, right? So 5 minus 2, it's 3. Then 3 is less than equal to 7. Yes. So how many such prefix we have? This and this. That means we have this array and this array, or required answer. So wedding. But I am sure that this will give a TLE, right? Because this is n square. Logic. Let me submit, and then we'll think for a better optimization. What is that optimization? Does this is also related to segment tree? No, right? Yeah, we are hitting TLE as expected, right? So what we can do is, max we can afford is, max need is k minus sum. This is our max need. We need to, somehow we need to get the count of prefixes whose sum is less than equal to need max. How we can get that? How we can get it? Chat. How we can get it? We are hitting TLE for sure. Because of this, I need a count of prefix sum. Prefix whose sum is less than equal to max need. There is one, but I won't, Policy based data structure. Policy based data structure. So this is actually a set which give you an index, find by order, find by order, order by key, multi-set, right? Yeah, this should help. This will help. Policy based data structure. I want to create a multi-set actually. Let's say ST. Insert 0. Okay. Then here, let's say ST, not set. ST dot insert sum. Okay. So our max need is this. So we'll find index st dot find by order or order by find. I don't remember actually. Find by order is used. Find by order. Order by key. Order of key. Okay. So I want index of a key. Order of key max need. Let's debug and see. What we are getting. Okay. 12000. I getting I forget how to use this policy based data structure. It's order by key or wait. How to use policy based data structure. Won't edit. I just want see you have created this is zero base count elements strictly smaller than x, strictly smaller than x. Yeah, this is what we want. 12000. Okay, see out max need. Oh, it's a set, right? I have to create a pair. This won't work, right? Here I have to change to this should work now. Four, 2, -1, -5, -10. Minus. Why minus I'm getting? Can we debug ST or not? Oh wow, yeah. Okay. 6. See, this is fine. Max need is 4. We are having 2 element. Max need is 2. We are still having 3 element. Max need is -1. Current sum is AI. And my target sum is K. Why am I getting minus? I'm not able to understand why I'm getting minus 7, 6, 15, 16. If count is greater than 0, then answer plus equal to count. What I'm missing here? It should be 2, right? Is a zero base. Count elements strictly smaller than x. That is what we are doing, right? Is there anything we are missing? See, max need is this. We have to count how many element. Count is 1, count is 2, count is 2. How? Max need is 7. Yeah. I think I'm doing something too crazy. Max need is 7, count is 1. That's good. Max need is 6, count is 2. This is also fine. Max need is 2. 4, 4, 7, 8. Count is 2. This is also fine. Max need is 1. Then count is 1. Max need is -4. Here's come the game. Max need is -4. No. See, my max need is -4. What that mean? -4, what that mean? -4 is currently I have big sum. Just I need to formulate this. Max, what's why I am stuck? We'll see this. No, I have to do this question anyhow. So easy question, right? My current sum is x. I want this x should shrink to 0 to k. Right. Minus is not possible. Why I'm getting minus? Here I'm getting minus, right? 0 3 1 4 4 8. This is 9. 14, right? 14 I am having. 14, that means I can 14, that means minus 14 is not possible. So my minimum sum should be at least 4 I should have. I'm confused here. Let me try this and we'll see. We have only 10 minutes. Prakash is choosing sorbents at his travel destination. Shop sells N type of sweets and M types of drink. The deliciousness of the I sweet is AI and delicious ठीक है. The satisfaction of combining the will get this. There are this combination. You have to find the sum of first case satisfaction. Can we do this in 10 minutes? This is also interesting question. Like, see, this kind of question make us to think, not to bore. See how interesting it is. It's look too simple, right? But the main thing is optimization. You have to think for the optimization. I personally love today's contest because today I didn't feel sleepy at all. Actually, sorry, I should not tell I'm not feeling sleepy. The point I mentioned, I felt not sleepy. I started feeling sleepy. I wait, will not try AI. Although it is for interesting question, we should not try AI. For a contest, at least we should not try AI. That's how we get to know where we are lagging. See, I know it doable with policy-based data structure. It is doable. It can also doable with lazy tree, lazy segment tree. Like the lazy segment tree, what it is, will get a sum of range in log n time. I think that's all for today then. I'm not able to think for optimization, or else we can wait for 5 minutes and we'll get editorial. Nice question. To deliver an package to an house, elevation of house is vi, one by one he will deliver. They are trying to say delivers are perform as follow. In each move he select exactly one unvisited house and move to it and mark it visited. The destination doesn't need to be existing house. He can move directly to the any unvisited house. The delivery is completed once all house has been visited. Exactly one. It does not matter which house he ends. Okay. He does not need to return to house one. The cost of moving directly on house one is this. In other words, the cost, the product of absolute difference is this. Minimize the total cost of n minus 1 move. Bit mask. We can do bit mask, right? 2 to the power 20. Just oh, it is a bit mask. Oh god. Let me try. Why I'm feeling it like it's a bit mask. Right? continue. Otherwise j is equal to 0, j is less than if I and 1 right side by j okay. No, we can't do bitwise here, right? Can't do bitwise here. And why? Can't do bitwise here. Because here we don't have choice actually, we have options. It's not like if we take visit or will take or leave. It's like from here we'll go here. From here we'll go here. It's like permutation. I want to see solution of C and I will think and will upsolve D and E. But for now I want to see how we can solve C. Now we can try. We are not submitting C, right? See, this is the question. And your current logic is closed but counting wrong side. I will quickly verify the exact fix. I'm telling you, right? It should be some minus k or what. What the fuck it is? This won't give TLE at all. Oh, it's a sliding window. Why? Yes, it is a sliding window question. Oh my god. Why I missed? See what exactly we have to do. We just need to maintain a window. Like, see, this subarray is greater than k. That means we can't include this subarray. So we'll remove this subarray, and we come to a boundary when this subarray is equal to k. That means we can take. So what I am trying to say in a fly is, see, we have A, B, C, D, E, F, G, H, I, J, K, L, right? So we know the sum of this subarray is k. Then of course the sum of this subarray is k less than k. This, like all the prefix, if you remove this, you got it, right? So what I'm trying to say is, here to here, we know the, like, sum of this subarray is k. Definitely the sum of this subarray is less than k, right? That is what we have to do actually. And we just need to maintain left is equal to 0, right is equal to 0, while L is less than n, sum plus is equal to A of R, and while sum is greater than k, sum minus is equal to A of L plus plus, and we just need to answer all the R minus L plus 1. That is all it is. What the fuck? They don't need this R. We need to do R plus plus. See, this is what it is. Contest is over. Okay, I want to submit. Okay. Focus. I have to focus from the next contest. Why wrong answer? Why wrong answer? Ah, God. Silly mistakes kill me one day, or what? There we go. Got AC. That's all for today. Thanks for watching. Bye bye.